Hi, I'm Professor David Farina. In today's lecture, we're going to be discussing the Earth and its moon, in particular, tides on Earth. Let's get started. So, what are tides and how are they produced? So, tides are primarily on Earth produced by Earth's moon. Earth's moon is a very large mass, and according to Newton's laws of mutual gravitation, it must be producing a gravitational force on the Earth. In fact, Newton observed the moon and the tides as one of his key pieces of information, his key pieces of evidence for mutual gravitation. So how do they work? How do tides work? First off, there are two main tides called diurnal tides on most places on Earth each day. Now, the first of these tides is caused by the moon and its attractive force on the ocean. Of course, this is pretty straightforward, but why is there a second tide on the opposite side of the Earth? This one's a little more complicated, but bear with me. First, we've got a high tide on the near side of the moon, towards the moon, near side of the Earth, because here the moon's pull is stronger and it pulls the water towards it. Pretty good. But on the opposite side, we have the moon's pull is weaker. And remember, the Earth itself, as this top diagram shows, is being pulled also towards the moon. And the result is that we have the Earth shifts from its original position over enough that we produce a secondary tide that's a high tide on this side, where the net force is smaller than on the Earth. So we have a larger net force, a medium net force, and a lowest net force, producing two tides. On the other sides, the perpendicular to the Earth-Moon direction, we've got the water being pulled away from these regions by the fact that the moon is over here. Now, throughout the month, you may know that tides change. And throughout the month, we have two very special types of tide that we need to discuss. First off is called the spring tide. The spring tide is a fancy way to say the highest maximum difference in tides in one single day. So we have a very, very high tide and a correspondingly low tide. In a 24-hour period, we have two high tides and two low tides during a spring tide. So you have the spring tides being produced at two positions of the Earth, Moon, and Sun position, because the Sun also does produce some tides as well. So when we combine the tides of the Sun and the Moon at the new moon, their directionality is in a straight line with the Earth. Or when we have the moon at the full moon, where there's moon, Earth, and Sun, once again, they're in a straight line, we can produce one of these spring tides. At two other positions of the moon, however, we've got the Sun, the moon, and the Earth, and they are perpendicular to each other, or at 90 degrees. And as a result, we end up with what's called a neap tide. A neap tide is the lowest change in tides throughout one day. In other words, your high tide is actually a little bit lower than normal, and your low tide is a little bit higher than normal. And so the variation in tides throughout a single day is lower. This happens when the moon is at third quarter or first quarter. Once again, notice they're at a 90-degree angle, Sun, Earth, Moon, and that's why we produce a neap tide. Now, it's important to note that these positions are about 1 week apart each. So the full moon is here, and then we have the third quarter moon, then we have the new moon, which would be here, and then the first quarter moon, and they are each about 1 week apart. So you have spring tide, then you have next week is going to be a neap tide, then you have a spring tide again, and then you have a neap tide again. So spring, neap, and it happens every month, but it has to do not with the calendar itself, but with the lunar cycle, which can be offset slightly from the calendar. One thing to consider, though, is that the orientation of this tidal bulge is offset due to Earth's rotation. In other words, the Earth is spinning on its axis, rotating each day. And as the Earth rotates, there are frictional forces that are involved between the ocean and the ocean floor, the Earth. And as a result, the tidal bulge is deflected or pushed just forward of where the moon's position is. Now, this is producing a drag force on the Earth itself. You can think of it like the Earth as a spinning bike tire. The ocean is almost acting like a brake caliper pushing down on the Earth. And just like in a bike tire, brakes slow things down. So the Earth is actually slowing down in its rotation, and in the past, the Earth's day was actually shorter than it is now. And in the future, the Earth's day will be longer because the Earth's rotation is slowing. But the conservation of momentum states that we must maintain this energy. So where is it going? The rotational motion of the Earth, the angular momentum, is actually being placed onto the moon through gravity. So what we're basically saying here is that the moon is speeding up. Notice the tidal bulge here is in front of the moon, causing the moon to accelerate towards that place. And when the moon accelerates or speeds up, it actually is going to gain altitude in its orbit around the Earth. In other words, the moon is leaving slowly. As the moon leaves, its effect on the Earth will become less and less, meaning the tidal forces produced by the moon are going to be lower in the future, and they were more extreme in the past. So this is quite an interesting topic, and I hope you look more into it. We can actually study, by the way, the Earth's tidal past by looking at layered structures called stromatolites. These are living organisms, and when we look at their cycle of growth, we can actually determine what the tides were doing at that time, similar to the rings on a tree and how we have trees getting different amounts of growth through each season. So stromatolites and looking at tidal history is something that scientists do when they're looking into the deep geological past, as stromatolites were one of the earliest life forms and possibly the first life forms here on Earth. Now, tides, as I said, are produced throughout the month on Earth, but tides also affect the moon. And the moon is going to show only one of its sides facing us at any given time. And the reason for this is kind of interesting and somewhat simple. The Earth's moon is actually heavier on the side that faces the Earth, or more massive. And as the moon turns around the Earth, we have one rotation of the moon for each lunar orbit. In other words, the moon does rotate, but it rotates once every time it goes around. It has a 1 month rotational period. So thanks for watching the Earth and its moon, Tides on Earth. I hope you learned something from this video, and if you did, please like this video and subscribe. And if you'd like to learn more about this and would like to get a notification each time I make a video, please click the bell at the bottom as you will get that notification. Thanks a lot, and have a stellar rest of your day.